but you can also have other BANET MSTP device. Okay, it's just that when the limits that they talk about is only related to the BANET MSTP beam. So for PXC modular and PXC compact, you can only have 6 maximum and less than 500 points. And then for PXG 3.M, this is how the network will look like. Okay, 480 points, less than 480 points, up to CC directly through the router. Okay. So we also have MSTP point pickup module. These are the different configuration. This is very simple device. In terms of point density is not very high, but the main thing is this is cheap, okay, made in China. In terms of the speed, it's not as fast as DXR, of course. So this is not so fast, but in terms of price, probably this is cheap. Okay, so some of you might want to consider this because of the price. And then we have a BANET AAC called the Unitary Equipment Controllers, but some of us call it UCM because of the part number. This is the point that the breakdown of the points on the PXC, or rather we call it UEC 16 or UEC 24. Basically, it looks exactly like our ARN controllers, which later I will show. The points are exactly the same. So what is the difference? So basically, it's a MSTP device. It's not IP. Because it is a BANET advanced application controllers, so it only trains its own points. So if you buy UEC 16 or UEC 24, you can only train these 16 or 24 points, and you can schedule these 16 or 24 points. Okay, and nothing else. You cannot do peer-to-peer. You can do it on programs, but you can't do it on trends and schedule. You can do local backup as well. You can have real-time clock. These controllers you can also use for AHU's applications. You can also use it to program multiple equipments like 2 fans, 3 fans, 2 FCU or 3 FCUs. Okay. So this UEC. And then for DXR, it's basically a BANET application specific controller. It can be BANET IP or MSTP, free programming. The programming is basically using our new commissioning tool. We call it the automation building tool. The programming style is block diagram. It supports web services. You can actually log into it using web. It is the same as the US controller. So basically all the US MSTP controller, except for the UEC, they occupy or they consume 3 BA credit on the 0cc license. So DXR consume the same thing. But the advantage of this DXR over the US ASC is that it supports KNX devices. So KNX devices for the IP version, it supports any brand of KNX devices. Basically, you use the tools to configure the KNX devices. It could be input-output devices. Like Siemens, we have input-output modules, small ones, big ones. So if you have not enough input points on the controller, you can actually buy and add them. So you can have more input points, output points. So you can pick up more points per controllers. Okay, and it still occupy 3 BA point license in DESICO-CC. And other than that, you can also use it for lighting control, shading control. You just need to buy Siemens lighting control or shading control modules. Okay, so that is the advantage of this. We call these the controllers can be used for total room automation. where you can control HVAC, which is could be VAV or FCUs. You can control lights and shades in the same room, okay, or in the same zone. So we have another control which is much more powerful than DXR, but it is also application-specific controller, and it is managed IP. It is free programming as well, block program, and support web services as well. Of course, the number of BA point depends on the model. Why? Because you'll notice that it has more data points than DXR. It has 140 or 280. Then it can support TXIO, which you can support up to 72 points or 200 points, depending on the models. You also support DALI. So, but generally, you must understand that the KNX points, the TXIO points, the DALI points, all add up together. You have a limitation of your data point, which is 140 for E72 model and 280 for E75 models. Okay, so this could be another powerful tools that you can have for simple programming. Do not try to use this controller for complicated programs like chiller. If you use this for AHUs, maybe still alright. FCU, yes, go ahead. But yeah, chillers, I would say, is a no-no because there's no schedule. Take note that there's no schedules, no trendings. Trendings, they have certain points with embedded trendings. That means pre-enabled trend. But for schedules, no. So it's free programs, but you can't really select your own points and create a new trend lock or create a new schedule, because ultimately this is only an application specific controller. Okay, but programs, no problem. You can use it for lighting control. You can use it for shades, because other than the digital points, point modules, you can also use the universal point modules. It supports triad control. It supports the relay control. It supports the relay for lights control. It supports the relay for blind controls. Okay, so I would say if let's say you are using BMS to control lights and you do not have enough DO points, I guess this is the controller that you should use, and you can actually use this for those applications. Okay. Any questions on the FLN devices? No question? Okay. Trend. By the way, the DXR E10 is actually for on-off control, and then E9 should be for modulating valve control. So 10 uses triad output. So you might need a relay for your on-off. Okay, so if you can't do or you have difficulty to program it, we will discuss offline. Okay, so any questions for the FRNs? Okay, no question. Maybe before I go to the next slide, which is a TXIO, because I've been talking about TXIO, so I will want to talk about TXIO. What's TXIO? The relay here for lights and the relay for normal control, the relay is a different bistable relay, single pole bistable relay. This relay is actually better suited for lighting control. So probably if you want to control lights, this kind of relay will be much better. Okay, that's just an additional comment. Okay, for TXIO technology, so we divided into in TXIO we have universal points. So our when we talk about universal point on TXIO module, we are talking about 0 to 10, nickel 1K, platinum 1K, 10K or 100K thermistor, or it can be set as DI or dry or pulse counter. Output will be also 0 to 10. If let's say it's a universal input output, everything is the same as a universal input points, but the only additional will be 0 to 10 output. However, if you buy a super universal, which is represented by the X, then you actually have all the features of universal input output plus 4 to 20 milliamp inputs and 4 to 20 milliamp output. And take note that for super universal module, you can have only a maximum of 4 numbers of 4 to 20 milliamp output. Okay, this is the limit from on the board itself, the PCB board itself. So just take note of these details, and also that the universal input or input output modules do not accept 4 to 20 milliamp input. Okay, later on I'll talk about the universal points on our ALN controllers. You'll find that the definition for universal point is different on TXIO modules and PXC compact or UEC. Okay. So if you're confused, it's okay. Come back to the same slides. So after a few times, you'll remember what it can support and what it cannot support. Okay, for our TXIO modules, they are self-forming, which means that you don't need to screw them together. It's just like Lego, you stack on top of each other. Okay, not on top of each other, side by side. There is actually a connection on the side. So you're supposed to stack them up. Okay, so we don't use a back plane. Okay, and on top of the modules, you can also find those AC and DC supply. Okay, if you need. But of course, take note that if you use this AC or DC supply, you will consume your power, your bus power. And also, we do have local overrides modules. So if you need modules that have local override functionality, we do have them. Basically, sometimes when you link a lot of TXIO together, when there's not enough bus power, you need to add bus power. Or when there's not enough space, then you need to go to the next DIMM rail. You can use our maybe additional power supply, bus power supply, or you can use another bus connection module. Later I'll talk about this too. But let's say you have a very big control panel. Maximum number of power supply per DIMM rail will be 2 numbers. Okay. Okay, another feature of TXIO, you can actually put labels, put in the labels and put in the names. Siemens do sell the labels, but I would recommend that you buy. Okay, sorry. I recommend that you print your own. Okay. Don't no need to buy from me. Okay. I don't think it's difficult to print the label on your own. And then another thing you need to take note that when we talk about the bus power supply and then you connect from the controller, you connect to other bus power supply or other bus connection modules. Maximum length is 50 meter, and from one end to the other end, meaning from beginning to the end. Meaning to say, from the primary controller where you put a power supply to the end, maybe the end could be a bus connection module. It will be 50 meters. Okay. This connection or this communication cable is actually called the island bus. Okay, so you cannot go too far out, not more than 50 meters. If you have any application that is more than 50 meters, we do have another way to connect them to extend maybe an additional 60 meters also. So if you have such requirement, you can let me know. I will help you, I'll advise you further how you can do that. But at the moment, just limit it to 50 meters. Okay, this is how you actually connect them. The electronic part can be actually separated from the terminals. This actually is a good practice because during your termination, sometimes the installer may terminate wrongly and terminate a 230 volt into the wrong terminal, and it might fry your PCB board. So sometimes it's good to just take out your PCB board during the termination. After you check through, it's okay, then you plug in the PCB board. Okay, so you can plug it. Okay, and all the TXIO module requires the address key. The address key part number are there. TXA1.K12 means it has address 1 to 12. K24 means it has address 1 to 24. K48 means that it has 25 to 48. And K72 means that it has 49 to 72. Okay, so depending on number of modules you need and what is the address that you need. If let's say you have a string of Bennett MSTP beam, and then you have a lot of modules. So basically you have more than maybe 25 modules. So you need to buy a K24 and a K48. Okay, so vice versa. So if you have more than 48 modules, so you need to buy K24, K48, and K72. Okay, so it's something like that. This key, although it's not expensive, but without this key, you will not be able to program or so-called configure the modules. Okay. The key is very important. Without the key, the module does not have a unique address, and that's the reason why you cannot program it. So very important. Small, cheap, but important if you are using TXIO. And in TXIO, basically, like I said, you have bus power supply. You need a 24 volt. It basically consumes basically it has 28.8 watts. You can generate 28.8 watts or 1.2 amp for the bus. So this power that you can generate is to support the TXIO modules. Every TXIO modules consume some ampere or some wattage. So they require those power from the power supply. And you can also use it to power up sensors. Okay. So you need this. Every controller cannot supply the power to the TXIO. So you need a power supply. For BNet MSDP beam, it can support because it actually has 14.4 watt to supply to the TXIO modules. So this is DIMM rail mounted. It can be, you can have two power supply in together in one DIMM rail. Maximum number of power supply used per controller is actually 4 on the paper, but we tried 6 before. It's still working but I don't think you should use 6 because 4 should be sufficient. The rest you can add a cheap unit called the connection module. So as long as there's enough bus power from the power supply, you want to connect to another control panel, you can use this bus connection module. Okay, you also need a 24 volt, so you also need to supply the 24 volt to this module, but it is not a bus power, so it does not provide power to the DXIO. The power comes from the power supply. So of course you need to connect the power supply CS/CD terminal to this bus connection module terminal. Okay, then after that, the bus supply can be supplied to the TXIO connected to this BCM in short. It also has a fuse. So just take note that currently we only have the 4M models, the power supply with 4M fuse and also bus connection module with 4M fuse. So currently we only have these two models. The 10M fuse model I think is already out, so I can't use the 10M fuse. Then the modules that is supported by our PXC modular or compact will be these 8 modules. DI, the 8 DIs, CO with rights, 8 UIO with 8 per universal, and 8 super universal with overrides. Okay, so these are all supported by our PXC modular and PXC compact. You'll notice that the PXC modular and PXC compact, our ALN controller, do not support the triad relay, the relay for lights and relay for blinds modules. Those modules, only PXC3 are supported. Okay? Just take notice. And you'll notice that super universal modules here is not supported by PXC3. Okay? PXC3 cannot be used for super universal modules. So 8 DI, their points are basically potential free, and they can be used for house counter 10 Hertz up to 10 Hertz. They have 3D integration for individual points. Their size all the module size is the same, but of course the point density for 16D is higher because you can connect 16 points, and the other one is only 8. Okay, and the B6BO. So you can set normally open and normally closed. They are Form C contacts. We also have universal. Universal pulse counter is up to about 20 Hertz. And I repeat again, they don't support 4 to 20 milliamp input and output. For the super universal, they are the same as the universal modules, but they can support 4 to 20 milliamp inputs, and per module you can support 4 numbers of 4 to 20 milliamp outputs. These are the part numbers and the description. I repeat again, the 12F10 and the EF10 is no longer available. Yeah. And this is a summary of the points and also the power that the modules consume. Take note that the number 8 doesn't mean that you can, example for 8U, it doesn't mean that you can connect 8DI, 8 nickel 1K, 8 platinum 1K, 8 10K thermistor in one module. No, it just means that if you use purely for example binary input, you can use all your 8 terminal. If let's say example for 16D, if I use it for purely pulse accumulator, I can only connect 8 of them. Same thing for 8X, you notice that for analog output 4 to 20 milliamp, one module can only support maximum up to 4. So the other 4 terminal, you can actually choose other outputs like 0 to 10. That is possible. Okay. Another thing that you have to be careful is analog input and analog output, active input and active output. Do not, if your analog input is external power supply, meaning to say your sensor is 0 to 10 or 4 to 20 milliamp, their 24 volt is supplied externally by another transformer. When the signal cable come back to TXIO, they should not be in the same, connected to the same module, because there will be a potential difference between the external power supply and our controller power supply. Okay, so that might fry the PCB. So in order to avoid that, don't put them together unless your supply for your sensor and your supply for your controller comes to the same panel or same controller. So if your TXIO is supplying power to the sensor, then no problem. You can have the input and output in the same module. No problem. Because their power potential will be the same. Okay? Just to take note. Okay, example. If let's say I need two 6R, two relay, and I need one 8 digital input module, and I have 4 universal module, and each universal module I have 4 actuators which I need to be powered by my module, and each actuator consume 10 VA. And then I have another 2 super universal module which supply power to sensors, DC power to sensors. So how can I configure? So this is the power consumption of each of the modules that I just quoted. Okay, and then you see the power supply voltage that they can give, 96 VA. Okay, given that your transformer that supply power to these TXIO units need to be more than this amount of VA. Okay, the power doesn't come from the sky. Okay, it is actually powered by your transformer. So your transformer, of course, must be bigger than 96 VA in order to supply 96 VA. Okay. So first, we consider the 6R. So each one consumes 1.7. So I have 25.4 watts left from my power supply. Then my D consume DC power, 24.3 now. My 8U after consuming is 20.7. But I have actuator, so it consume my AC power. Since my AC power is already 16, so I still have 8 more actuator to support, so I need to get a bus connection module. Okay, notice the DC is still the same because the DC still comes from your bus power supply. So it remains, but your AC is being boosted up to 96. So minus away your module DC power and also your actuator DC power. Then your sensor consume DC power and your module consume DC power. So at the end of it, the total amount of DC power you consume is 20.9 watt, which can be supplied by your power supply. And the AC is 160 VA. That's why you need the bus connection module, additional bus connection module for the VA. Okay, so this is how you do it. Of course, you can choose not to use the AC from the TXIO module. You can choose to use the transformer to provide the AC. That is also fine. Okay, so this is just an exercise to show you how you actually size your TXIO modules if you are using power supply on the module itself. Okay, so this is how the connection will be like. So make sure your input power, your transformer is more than 160 VA. Okay, another exercise. If let's say I have 56 points, 36 DI, 2 10K thermistor, 6 4 to 20 milliamp output, 9 DO, and 3 numbers of 1K nickel. So which modules to use, select, and how many beams do you need? You need additional power. So basically, you have 6 considerations. You always consider the DO first. Then, in this case, the DO is 9 DO. So I need 2 6R module. And then I consider the 4 to 20 milliamp output. So in this case, I have 6 4 to 20 milliamp output, and I know each 8X only can support 4 numbers of 4 to 20 milliamp output. So I need 2 number of 8X module. And then I have to consider 4 to 20 milliamp inputs. In this case, I do not have any. And I need to consider the active input and output, whether it's external power, things like that. In this case, there's no other active inputs or outputs, so it doesn't matter. Then you should consider the passive input. In this case, I have 5 passive input, which I can put them into 8X. Because 8X, I have remaining 10 points. So I have 5 passive input minus 5. So I have 5 more points on the 8X. So I have 36 DI. The last one is considered DI. So I have 5 more DIs, 5 more points on the 8X left. So 36 minus 5, that is 31. So 31, I need 2 numbers of 16D. So for this exercise, I need 2 numbers of 16D, 2 numbers of 8X, and 2 numbers of 6R. Total is 10.6 watt. And my bed net MSTP beam can support 14.4 watt. So I only need 1 number because the point count is 56. It didn't exceed. The modules is 6 only, so it doesn't exceed the limits. And the power, it did not exceed the limit. So I only need 1 magnet MSTP beam. Okay, so this is how you do. So I do this exercise. The important thing is this page where you see the different steps, how I consider, what do I consider first when I do a TXIO sizing. So I hope you benefit from this, because a lot of times you do not know how to proceed incising the TXIO. So I hope these 6 steps will help you. So in summary, the bus for the TXIO modules is self-forming. The self-forming bus also transport both power and communication. And then there are also LED lights on it, so you can see whether is it configured or is there error by looking at the LED, whether it is flashing. Flashing means errors. So you can check on the data sheet of what errors. The TXIO module can also supply AC or DC power for sensors or actuators. Then you can have up to 4 power supplies. And just take note also that the island bus network can only be distributed up to 50 meters unless you deploy IBE. Okay, which if you need that, please come back to me. So at the moment, just take it as 50 meters for the island bus. And then the total number of modules that is supported by our US ALN controllers is only 8 different types. Okay. Any questions on TXIO? Okay, no question. Continue. Do you need a break? No reply? Okay, then continue.
Excuse me.
Again?
Do you hear me?
Yep.
Hello?
Again?
Can you give me the example of input and active input?
Again, say again. I didn't catch the last part.
I didn't catch the last part. Can you give me the example of passive input and active input? Give me some example.
Okay. Okay, you look at the analog input. Basically, resistive are all passive input because they do not need additional power. So like temperature, nickel 1K, platinum 1K, NTC 10K or 100K. These are all by ohm. So they do not consume power. They do not need 24 volt or 24 DC. But where else those voltage input like 0 to 10 or current 4 to 20 milliamp, those inputs, they require 24 volt AC or DC depending on sensor. So those that require 20 additional power like 24 volt AC or DC, they are called the active inputs. Resistive inputs are called the passive inputs. So in terms of cable, resistive is only 1 pair. For active, it's actually 2 pair. 1 pair for the power and 1 pair for the signal. Does this
okay, thank you.
Okay?
I get it.
Does this
okay. Yeah.
Okay. All right, proceed. Okay. So go back to the architecture. We finished the FLNs. Now we go to the ALNs. So basically, ALN controllers is the heart of our DDC system. Basically, at this level, you will have programming. You will have for the US system, we have programming. We have all the point and program database at this level. Scheduling, I/O monitoring, or supervisory controllers are usually at this level. We also support trending, alarming. Also at this level, we do have integration platform to third-party systems. So there's a list of drivers that we have. Okay, but like I said, recent years, we realized that less and less of these integration drivers is needed. Mainly, we only need the Modbus driver most of the time. Okay. Other than that, so far, no other partners buy the drivers except for Modbus drivers. Yeah, so far only Modbus drivers. Maybe Siemens Security integration drivers. But other than that, no. We do have a driver called the for BNet MSTP drivers. They are for special applications. But usually our FLN, we can actually connect to a third-party BNet MSTP devices directly. So we do not need an integration driver. Okay. So far, most of you will order Modbus driver. That's all. Which I will cover that later on in my slides. So at this level, you can also have a built-in operator interface. We at this level is also usually the BNet IP. So we have a free programming or free software called Launchpad. You can use it to configure. You can use it to edit the points. Yeah, and at this level, you can do schedules. And then at this level, or basically our controllers, we actually have increased our security in terms of access. Now, when you get any controller from factory, before you can do any settings, they ask you to change your password. So you cannot use default password anymore. So you know the basically once you know the default password, the next thing you need to change the password. Okay. So now for me to access to any new controllers, I have to depend on you for the password because I will not have the password. And then at this level, you will have alarming. So you can do alarm, you can do event enrollment alarm, okay, for the FLN devices as well. And I emphasize again, we emphasize on the investment protection. So even from old controllers to the current controllers, we have migration plan. So it's easy to migrate. So whatever database you have in the old controller, you can just use this database and put it in the new controllers. It's that easy, okay? So let's start with the first controller in this level, PXC modular. Basically, why is it modular? So whatever points you want, you buy the TXIO module, okay? But on itself is basically a programmable controller. On its own, it supports program schedules and trendings. Okay, it has a self-forming bus on the left side and right side. So on the left side is for the RS-485 port expansion, which you can use to connect P1, which is a proprietary FLN, or BNet MSTP, or if you have the Modbus license, you can buy this for the Modbus RTU network. Okay, so this is how you connect. There's no screw, it's just self-forming bus. So on the right side is for TXIO. So if your controllers support the TXIO modules, then you can actually add a power supply and add the TXIO self-forming bus. And PXC modular support up to 500 points or up to 64 modules, whichever comes first. So you see a power supply in the middle, okay, because PXE modular cannot supply power to the TXIO. That's why you need power supply. You may need more than one power supply for a large number of points. And from my experience, for a usual standard average size control panel, most likely you need bus connection module because you have 2 DIMM rail in one control panel usually, and then usually you will not be able to put a lot of TXIO module in one DIMM rail. So it's always wise to buy extra bus connection modules because you never know when you need it. Okay, so if you buy the right model of PXE modular, you can have both the port RS485 port expansion and also the TXIO modules. So there is 2 models of PXE modular. One is called PXE00 E96.A. This one do not support the TXIO. Of course, you can add license to it, and you can. Then after that, it will be enabled. Okay, but when you buy it from factory directly, it does not have the TXIO module license, but it does have your FRN license. So you can buy the PXX485.3, which is your port expansion for your MSTP FLN, or you can use the RS485 port for the MSTP FLN on board. So if you don't mind to use only one port, you do not need to buy the PXX485. If you want to have 2 port, then you buy PXX485. Whether you use 1 port or 2 port, the total number of MSTP devices that it supports is recommended to be 50 to 60. But if your MSTP devices are all DXR, are all UEC, the AAC controllers, then you might be able to stretch it to about 80 devices. But if it's a mix of our ATECH, mix of the PPM, mix on other devices, third party, then I'll recommend it to be about 50 to 60 for acceptable performance. Okay. So this controller with Modbus license, the PXX485 can be used for Modbus RTU. It can also support Modbus TCP. So if you buy the PXC100-E96.A, straight away from out of the box, you can actually put the power supply and TXIO on it, and it has also FLN. Okay. So it's exactly the same as PXC00, except that the license for TXIO is enabled. Next, we have the compact. So compact comes with physical points. Okay. So we have altogether 3 sizes: compact, PXC16, PXC24, PXC36, and all the points are there. So you realize that PX16 do not have super universal, which means that it cannot have 4 to 20 milliamp output. But the universal points, the input points and input-output points here, they actually support 4 to 20 milliamp inputs. Okay, this universal definition and the TXIO universal definition, there's some difference. Later I'll show you. So PXC24 supports 4 super universal, and PXC36 supports 6. You will, when you do sizing or design, you will need to memorize the point breakdown of the PXC compact so that you can do your estimation faster. How I remember It's very easy. I look at the DO points. PXC16 have 3 DO points. PXC24 have 5 DO points. And PXC36 have 8 DO points. So this is something that is unique. And this is something that probably you don't use. And you can't use it for any other things. Okay? That's why it's something that's standing out. Just like TXIO, I start with the DO points first. Then the other one is the analog output. PXC16 has 3, PXC24 has 3, PXC36, none of them. So in this region, usually the output points we don't use so many output points. For one AHU, I probably have only 1 start stop or 2 start stop. Then I probably have 2 or maybe maximum 3 analog output points. So I don't use a lot. So I remember this 2 point type. Because after remembering this point type, 16 minus 6, I have 10 points left. 24 minus 8, I have 16 points left. 36 minus 8, I will have 28 points left. All these numbers means input points to me. Okay? So basically, if we meant input points, basically what we have for a lot of application is input points. So I just need to remember that 16 have 10, 24 has 16, 36 has 28. So it actually helps me a lot in my sizing. Okay? So that will be the magic number lah. So this is the universal points is exactly the same as TXIO modules, except that 4 to 20 milliamp is included, input is included, but 4 to 20 milliamp output is still supported by the super universal. And PXC Compact comes with different model. PXC16 or PXC24.2-E.A, which is the E means the bandit IP. PXC16 or 24.2-EF.A, the F means there is an additional RS485 port, which if you have the license, RSM FLN license, you can connect to MSTP FLN or P1 FLN. If you use the Modbus license, you can have Modbus RTU, FLN, or even TCP. But if you buy the PXC 16/24.2-EF32.A, it means that the factory has preloaded the LSM FLN for you. Straight from the box, you already have the FLN enabled. You do not need to give Siemens separate PO on the LSM FLN. Okay? So if you need FLN, please buy EF32.A. If you don't need FLN, and you know that you don't need, you just need to buy E.A or EF.A, just in case. Okay? So PXC36, you have 2 models. One is -E.A, one is EF.A. So the E.A is a basic. It only has a physical points, 36 points, 8 DO, 28 inputs. If you have FLN, you have FLN. The 2 black color terminal will become the FLNs. If you buy the island bus, then the white color terminal will have the island bus where you can add 4 TXIO module with power supply. So you still need power supply. Or you can buy the Modbus license and you can have 2 Modbus FLN. If you buy the EF.A, basically you have the FLN, you have the island bus enabled. Okay. So, summary, they are all building controllers. So in BTL, they are classified as B-BC. PXC16 and 24 support up to 32 backnet MSTP device with the FLN enabled. but I recommend 20 device for acceptable performance. PXC36 support up to 50 recommended, can stretch out to 80 if all the devices support COV subscription, example DXR, PXC3 or UEC. Okay. PXC36 can also, with island bus, it can extend up to 4 TXIO modules. Okay. So this is the ALN. So on the Modbus integration side, we can have PXC00, where you can buy 4 type of license. NDBS 250, which is 250 Modbus point, 500 points, 1000 points. Without any number behind is the full license, which is around 3000 points. So every FLN, so if you have to buy the PXX485 in order to have the 3 numbers of RTU port. Each RTU, you can only have 32 devices because of electrical load. Okay. Don't care about what Modbus tell you, but electrical load, take note of that. Modbus TCP is the same as long as you are on the same TCP IP and the same subnet. You can actually communicate directly. It also supports web services, which means you can log in using Launchpad and do editing. It supports trending, schedule, and programming. Okay, you can also buy the PXC100-E96.A, and then you put in the Modbus. It can support Modbus plus IO modules. Okay, but in total, one controller do not exceed 5,000 points. Whether is it virtual, whether is it virtual, whether is it physical, or whether is it Modbus, total is 5,000. If you exceed or you have a lot of trends, then your controller will tend to cold start a lot of times. You can also use PXC36-E.A and add in the Modbus license. Okay, but compared to PXC modular, you only have 2 RTU Modbus FLN. Okay, because you only has 2 RS485 ports. The rest of the thing is same as PXC modular. You will notice that I recommend you to buy PXC36-E.A, not EF, because you don't need. Okay, unless you want the island bus. Okay, if not, then I will recommend you, if you want the island bus, just buy E.A, Modbus license, and island bus license. It's much cheaper than buying EF.A and then buy Modbus license. So, okay, there is more cost saving. So same thing, if you only need the FLN, you don't need island bus, you can buy PXC36-E.A and then plus FLN license for PXC36. Okay, now recently, our PXC16 and 24 EF.A, you can actually buy these 2 Modbus license, 250 and 500. You can load them and then you can use it as a Modbus driver. So this is a cheaper alternative because these controllers are much cheaper than PXC modular or PXC36. Okay. Of course, you need to buy the model with the RS485, but you do not need to buy EF32.A because your FLN will be converted to Modbus RTU, so there's no need for you to buy the FLN license. Okay, so rule of thumb, when we talk about 250 points or 500 points or 1000 points, rule of thumb is if you have, let's say, 200 points, okay, from various devices, then I will recommend you to buy 500 point license. because the speed is one issue. Of course, if you are not concerned about the speed, your customer is not concerned about the speed, then no problem. You can go ahead to buy 250. But in case your partner, your customer is particular with the speed, then you can go with the 500. The reason is with more points, you can actually, doing your programming, you can actually make it more efficient, so that it is easier to update. It's fastest to do the updating. Okay, you can configure it such a way that it's faster in updating if you have extra points. If you don't have extra points, what you have is what you get. You can't do anything. You cannot make it more efficient, okay, because you are limited by your point count. Okay, so that's my advice. Okay, so that's the end for the ALNs. Any questions? Okay, no question, then I proceed. Okay, the Zero CC, I will not go through everything because I'll have another online training on the Zero CC. So I'll just briefly tell you the overview. Basically, the Zero CC, we built the Zero CC as a common platform for Siemens system. So Siemens BMS, Siemens Fire will all use the same platform. And Siemens security, whether is it access control or whether is it video management system, they can be integrated easily to the Zero CC. Okay, so why common platform? So that in one platform you can have you can see multiple discipline, and then the workflow is consistent. So whether you are looking at fire system, BMS system, power system, lighting control system, whatever system that is integrated on this platform, the workflow is the same. Okay, how you navigate, how you assess the points, how you do trending, everything is the same. So interface is the same. So for operator, it's very easy. Okay. So then the other advantage of the Zero CC is the global standard. So you can, like I said, it has you can read partner IP, OPC, DA, UA. You can have SNMP, S7, Siemens S7, a lot. And if you want more, you can build driver for it. And on the northbound, you can interface with enterprise software via REST API. Okay. So these are the features of the Zero CC. So it's SAL1. It supports certificate exchange. That's for security. It's vector graphics, and it supports AutoCAD import. So the vector graphic is when you zoom in to the, you can zoom in. Let's say you build an overview of a chiller plant. You can zoom in to chiller. There will not be any loss of resolution. Okay, that's vector graphics. And it supports multi-layers. You can do a lot of things in the graphic because we have very powerful evaluation. You can make your alarm point blink. You can change the font when it's in alarm. You can make something visible by a trigger point, things like that. There's a lot of things you can do. And for the alarm and events, we have assisted treatment, which is usually used by fire. Now we have assisted treatment. You can use it for BMS. It comes with the standard feature set. So when any critical alarm or something that alarm that is critical, but usually it will not happen. A lot of people will not know how to deal with it. You can have it assisted treatment for this kind of alarm. So you can build SOPs, different steps for the operator to follow, so that the operator will not be panic. And we have related items you can use. Anything related to the points, maybe like trend, maybe the schedule related to the points will be shown under related items. We have reports, we have advanced reports, very powerful report engine which you can use to customize special reports. Integrate with our BMS so that we can do recording, things like that. Schedules, we support schedules on backnet controllers. We also support server schedules. That means using the DKATECH, you can schedule points on active, inactive, things like that. You can also have trends on server or trends on controllers. Reaction, we support event triggers. We also support logics, JavaScript. Okay, and we have multiple interface for different protocols. And on the user side, a lot of things are customized. The profile, what you want to see, what you can do, the languages can be customized. So these are the highlights of the feature for the DKATECH. Okay. So in summary, for Siemens BMS system, we always leverage on the industry standard to provide an open system solution. Usually our BMS is a 3-level network, management level, automation level, and field level. In field level, we have application-specific controllers for dedicated mechanical system, and we have the largest range of application in the industry. And for us, our automation level is the heart of our system. Okay. And our management software now is the DKATECH, which is our system one, and is used in any countries in the world. We'll be using the DKATECH. Okay. So if you know the DKATECH now, you go to Europe, you go to US, and they have Siemens BMS, you will know how to operate the DKATECH because it will be the same. Okay, any question? So far so good. Is it helpful?
Gabriel?
Yep.
Could you share to us any information on the UEC? I heard from a college from US that UEC shall be phased out recently. In the near future.
As long as there's no announcement on the retirement of UEC, you will still be around. Anyway, with the announcement, there will still be 7 years of support. So no issue. The new controllers, there will be new controllers coming out next year on the ALN level. It will be system 1. It will be something to so-called replace UEC, but I don't think it will actually replace UEC yet. But we shall see. If this new controller is out and you start to buy this new controller instead of UEC, I would say that it's an achievement because you prefer this new controller over UEC. Okay? And this new controller will also be, I think the first version will be IP, and then probably the next version will be MST.
Okay.
Em gửi đi.
Okay, so just remember, any new controllers will be out. Will be supported by the new commissioning tool. That is the ABT. Okay, automation building tools. So we are moving away from the US controller. So if we move away from US controller, then the combination tool will also be different. Okay, but in the meantime, we need to learn a lot of tools at the moment.
Excuse me?
At the moment, we need to know a lot of different tools because we are still using some part is from Apogee, some part is System 1.
Okay.
Okay?
谢谢.
Okay. Any more question? Okay. You notice that I have spent about 2 hours talking about the product of Siemens BMS, but I have not addressed anything on BATnet. So for all of you, if you want to know BATnet, I would like you to go to our extranet. Go to our extranet and go and listen to the BATnet online training. If you do not have access, please ask a country rep, Siemens country rep, to direct you to the website and to sign up for the account. It's very useful. There's a lot of information inside. Information on our products, information on BATnet, information on our new ABT tools or the Zigo CC videos, tutorials are all there. And the software are also there. So you can download our software from there, download the patch from there, download the libraries from there. Okay? So do sign up for this extranet. And do use them. Do check them regularly, okay? So, let's see. For the classroom training that's coming out in the end of this month, it will be a technical training. So, those who are coming, please give your details to the country rep because I need them. I want to know who's coming, and then whether I have enough space for you. And the other thing is I will send some theory exam to you so that you can do it first before you come for the training, so that I know where you are in your understanding of our products and on BATnet. So for BATnet, you need the BATnet online training to help you, okay, at least pass the test, the theory test. If not, when you come for the classroom training, you may not be able to catch up. So important is, you need to go through the BATnet online training, and then you need to go through this product training again. If you forget, I will send the material to you. I will send later after the training. I will send the slides to you. I will also send the data sheet to you. Okay, to you means I will send it via this circuit, and then the country rep have to send it out to you. I will also send you some useful information, okay, so that you can actually refer to them. Okay. If there's no questions today, initially I wanted to go through 3 exercises, but then I realized that it's quite hard for me to show you other exercise. As in some exercise, it's very hard for me to show you. So I will show you 2 exercises on my slide. And then for the third exercise, I will open it up and then show you how I would approach it. And then after that, I will also send the exercise on this circuit. And those who are coming for the classroom training exercise, please do the exercise and send to me. Okay? I hope I will not scare you off because there will be tests and tests and tests and tests. But all these tests is the aim, the objective is so that I know how much you understand from the training, how much you understand on our product and on the protocol, so that I will know where to start for the hardware training. Okay? So when you sign up for the classroom training, please give me your full name, your company, your email address. Okay? Thank you. So now I'll start with exercise 1. So for a start, if let's say you are given a AQ point like this, how do you how do you generate the point list? In the BMS training, I show you a rough steps on how you do it. So I'll show you again. So if you have all these points, what should you do? Okay, first I will consolidate the points into a table. Then with DI, DO, AI, AO. Then anything that is analog will be analog. Analog input is something that the controller will read. Anything that is controlling, that means like control valve, CV is control valve. So that's analog output. Then anything that is 2 position, there will be something like fresh air damper, which can be 2 position or which can be modulating. So depends. If it's 3 position, there will be 2 DO. If it's on off, it's 1 DO. Modulating is AO. So let's go through the list. RAT is basically return air temperature. So it's a temperature, it's a real value, so it's analog. And it's a temperature, so it's an analog input. RAH is return air humidity. So it'll be analog input. CO2, analog input because we are measuring CO2 level. Fresh air damper is something that we want to control. Okay. Because of CO2, we also want fresh air. With the CO2 level, we will determine when to open the fresh air damper. So it's a DO or AO. Control valve is for temperature or RH control. So it's usually for AQ is usually analog output. Chilled CHWST, chilled water supply temperature. Chilled water's return temperature. Those are all temperature readings, so it's analog input. FA is filter alarm. It's a status, DI point. Flow using from flow meter, so it's a real value, so it's analog input. VST command is usually analog output. Supply air temperature, input, analog input. SP is static pressure, so it's reading as well, so it's analog input. SS is start stop, so it's DO, digital output. ST status, input, digital input. TP, trip status, so it's DI. Auto or manual, AM, so it's all DI. So I will put all the points in the table and then generate out my DI, DO, AI, O table, and then I'll consolidate them. And from this total number, I will check. First, I will check the DO, 2 DO. So I can use PXC16 or PXC24. Both can support this number of DO. AO, 2. So PXC16 or PXC24 can support. The AI is 9 and DI is 4. 9 plus 4 is 13. PXC16 cannot support 13 points. PXC24 can. So I can use PXC24. So out of PXC24, the cheapest one is UEC24. So for this exercise, I will use PXC24.3-UCM.A for the AHUs. Unless they specify that it needs to be BATnet IP, then I will change it to an IP controller. Okay, but I know that PXC compact with 24 points is needed for this AHU. Okay, any question? Can you follow the flow? No question, I assume everyone can follow. Because this is the most basic step. Okay, last week I sent out a sample control write-up with sample points for different kind of applications and equipments. So using that, you can come out with this kind of table and design the suitable controllers for the equipments. Okay, in Siemens BMS, we try to give all the major equipment its own controller. Okay, so it is like distributing the egg into different basket rather than putting all the eggs in one basket. Okay, so certain equipment I will use one controller. AHUs I'll try to use separate controllers. So for exercise 2, imagine I have 20 AHU, 2 pre-cool AHU, and 3 set of trigger system. So every AHU have to be standalone in the event of communication failure. So which means every AHU should have their own controller. Then at the same time, there's 50 RTU Modbus power meter and 20 Modbus TCP devices. So we need to cater for that. And the total number of points, Modbus points from all these power meters and device will be 1,006. So we have to use a full license. So I'll start from AHUs, assuming that all AHUs are the same. So I get a rough from their control strategy diagram or things like that. I will come up with a list of points, and I guess this is my AHU point count. Okay, so this is my pre-cool AHU point list. Okay, and this is my chiller point list. My chiller, chill water pump and condenser water pump point list, and my cooling tower point list. Okay, so for my chiller plant, I will try to use one controller. That's why I total up the points. And with the points, using the same principle I mentioned before for TXIO, I came out with this modules. So I'm using PXC 100 for my TXIO for my chiller system. I use the PXC 00 for my Modbus integration, and I use 20 numbers of UEC 24 for my AHUs and 2 numbers of EF32.A PXC 16 for my pre-cool. And this is my schematic. So I'm using the PXC 16 for as a ALN controller as a route back to the ZCC. Okay, this is to save cost. Any question on this? Thread or Susanto, do you have any way to reduce the cost? Thread, Susanto, are you there? Or any one of you, are you able to reduce the cost for this exercise? No one? No one can do? No one can. If no one, then maybe I give you a suggestion. I mentioned before that the PXC 16.2 EF32.A can support probably 20 numbers. So recommended is 20 lah. So instead of using two numbers of PXC 16.2 EF32.A, I can choose to use one. Then the other one will be the UEC 16. So I will have about 21 units. Okay, I mean that's okay. If you prefer to do that way, it will still work. Of course, if your control is down, you will not be able to see all the other controllers using the 0cc. Okay, so that is one. So it's up to you, but it will definitely reduce some costs. Not too much, but it's a bit. The other reduction could be your Modbus license can be put onto your chiller controller, chiller plant controller. So though this is not the perfect solution, this is a cost-saving solution. But thankfully, the number of physical points you have is probably about 100 points. So include plus your Modbus points, so probably about 1,007 or 1,008. I think should be fine. But personal preference is if you can separate them, you'll be good to separate them. Okay. So take note that other than these parts that you need to buy, there are some stuff that I forgot, I didn't add. So I hope that you remember that whenever you use TXIO, you will need to buy address key. Okay, so altogether there's actually 12 units, so you need to buy 12 K12, which is 1 to 12 address. You can also buy 24 as a spare. It's really very cheap. So without that address key, you won't be able to do commissioning. Yeah. Okay. So that's for exercise 2. Any question?
I'm putting the topic of my discussion as visualization, and then we talk about the UCC and so we'll do a short intro. Be there with us. They can ask you.
Okay, if no question, we go to the last one, exercise 3. So exercise 3 have multiple equipments. You see the quantity, and you have a lot of fan. So sometimes this kind of configuration makes it very hard for us to size. So what do you normally do? Okay, for this one, I will not give you the answer yet. I will show you how I work. Okay. Let me share my desktop. Okay. So, okay, first, the question is exercise 3. Okay, I won't follow the exact question. So basically, you are given the schematic like this. There is a lot of fan, and the good thing is all the equipments are given to us in the respective floor. So take note, if you have no information from your main contractor, the best way is to ask. Some question you need to ask is for the equipment that you want to control, and where are they, at least in terms of the floor. Because if they don't even tell you where is it in the building, it's very hard for you to come up with the sizing. So that will be even more not accurate. So with this, at least you can consolidate the equipments. Okay. So of course, with this, the first step I will do is I will consolidate the equipments into their floor. Okay, different equipment in their floor, and then every equipment we are given the point count already. Okay, we are already given the point count. So with that, with all this, we can start to consolidate them into different DIDO, things like that. You can even separate them into left and right visor. So after that, you can deploy different controllers. So example, this case where you have one DI, two DO, so you might want to consolidate like 3 level and then use a DXR E18 where you have 6 DO, or you want to maybe consolidate for them and then use a PTEC, because PTEC has 8 DOs, things like that. So you can actually consolidate them by different level, different riser. Then after that, you have to account to the number of MSTP device. After that, you will look into the number of, for example, option 1. After doing that, I have a lot of PTEC. Okay, with this number of PTEC, I need to determine how many ALN controllers as a supervisory controllers. And then how many I can consolidate so that I can use UEC 24 or UEC 16. Also, I can also consolidate them into a bigger PPM, more floors into one PPM, and I can also consolidate them to PTEC because of the number of DO points, or I can use PXC3. Okay, because I can use a lot of DO, it has a lot of points, so I can actually consolidate even more floors together. So there's a lot of permutation, there's a lot of controllers that you can use. So it really depends on you. Okay, depend on how comfortable are you in commissioning them, how comfortable your guys are in commissioning them. If you want to use a purely US Apogee system, then you are going to the direction of PTEC, UEC, PPM. But you are more adventurous and you want to try the new solution, ABT, then you must be aware of ABT, and you can use BATnet beam, you can use PXC3, you can use DXR, and with combination of UEC and PXC compact and PXC modular. So you can go with that. Okay. The idea here is there's a lot of possibility. Can be price, can be engineering hours. Okay. So when you are not comfortable with certain system, probably you can choose not to use them. Example, ABT. If you are new to ABT, maybe you don't want to use them. But if you want to use them, you can start to learn how to use them. Okay, for PXC3 and PXC3, you need to use ABT Pro in order to configure it. For DXR, you can use site, you can use Pro. But if you need using DXR and PXC3 for a lot of points, most likely you'll be using ABT Pro. Okay, but if you're using BATnet Beam, ABT site will be sufficient. Okay, and it's very easy to program, very easy because you can use ABT site, you can use a phone app ABT Go to configure your BATnet Beam. Okay, so you're talking about easy to configure, then probably our US controllers and BATnet Beam will be easier to configure. But if you are already trained in ABT Pro, then you can go for DXR or PXC3 solution. Okay, so that's all from me for today. So I will try to do up a different combination using maybe US system, and then another one with the new controllers or BATnet Beam, and maybe another one using PXC3 and DXR. I mean PXC3 basically using ABT Pro solution. So one will be not using ABT, one will be using ABT site, another solution will be using ABT Pro. So you will take a look and I try to give you an indicative price to see the difference. Maybe that will encourage you to learn ABT. Okay. So any questions? Any questions? Anyone? Any questions? And what other things that you need from me? Or all of you are sleeping already? It's a long training, 2.5 hours. Okay, if no question, that's all for today. I will stop the recording. Okay, thank you.